Hi everyone, in this video we are going to be looking at conditional probability. This is the topic that is probably the trickiest one in probability. We've dealt with the simple things, simple ideas of probability, rolling dice, tree diagrams, Venn diagrams, sets and all that sort of thing. So we're going to put this all together now, looking at conditional probability. So this is when we're talking about probability where one event depends on whether another event has occurred or not. So I'm going to show you a number of different examples of how this can work. So if we have like counters in a bag, the classic probability question, we take out a counter and don't replace it. Then whether we get a red or a blue counter on the second draw depends on what we got on the first draw. Because if we take out a red on the first draw, now we've only got one red out of the total 4 left in the bag. So there's a 1 in 4 chance or a quarter chance of getting a red on the second draw. But if we get a blue one, now we've got 4 counters left, 2 of them are red, so it's a half chance. So the probability changes depending on what happens. So we're going to look at tables, Venn diagrams, and a tree diagram. So I'm going to do 3 examples here to look at. Firstly, the table example. Now, for the table example, you'll see that we've already done this kind of thing before. So I'm just going to formalize it a little bit with the formula. So the notation that you're going to need to know here is this one right here, probability A and the straight line B. That means the probability of A happening given that B has already happened. Okay, that's the formula, or that's the notation that we're going to use for conditional probability. Let's look at the example here. First one, types of car grouped by petrol consumption, owned by 100 different people, categorized as either male or female. So we've got the event, the person owns a low-rated car, and the event that the person is a female. Okay, so we want to know what's the probability a person owns a low-rated car. We could draw a Venn diagram for this, but it's just easier doing the column totals and working it out. So 35 people own a low-rated car. The total number of people we surveyed was 100. So 35 over 100, you could do a bit of simplifying, 7 over 20, or you could write that as 0.35 as well, as a decimal. What's the probability that the person we choose at random is a female and owns a low-rated car? Let's look at our table. There's 23 people out of a total of 100, so 0.23 for that one there. Now, here's the different one. What's the probability that we choose a female given that we've chosen a person who owns a low-rated car? Okay. So now things have changed. Now instead of considering all of the 100 people, we're only dealing with the 35 people. Okay, that's the tricky bit here. We've said we've definitely got someone who owns a low-rated car. So we've now, our sample size has gone down from all the 100 people. We're now looking at just those 35 people that own the low-rated car. Of those, 23 are female. So the probability is 23 out of 35 for that one there. And we've done similar problems like this before. So the question that I could ask there is, say, what's the probability now of, given that we've got a male person, what's the probability they own a medium-rated car? Okay, these little formulas here are going to be really helpful, and I'm going to get back to those. Second one, this one's going to be a Venn diagram. We've got 2 packets of seeds, one has 20, and they look the same, 8 are red and 12 are blue. The second packet has 25 seeds, 15 will be red and 10 will be blue. Alright, so R is the event that we get a red flower, and F is the event that a seed we choose at random comes from the first packet. Okay, so how many seeds are red and are in the first packet? That's 8. How many seeds are in the first packet? 20 seeds, so that means there must be 12 blue in the first packet. What's the total number of red seeds? Well, we've got 15 in the second packet and 8 in the first, so that means that one there must be 15. If we add all those together, we get 45, and the total number of seeds that we had was 55, so therefore 10 is on the outside. So we've got our Venn diagram now. Now we can ask the question. So there's 45 total. What's the probability that we get a red seed and it's from the first packet? So that's the intersection part there. That's 8 out of a total of 45. Easy. 8 out of 45. What's the probability now? Here's the conditional part. What's the probability of getting a red seed given that we take a seed from the first packet? All right, so given that we've got the first packet, so it means that, forget about the second packet, we're only looking at the first packet. So we're only looking at this circle here. You can see the total number of seeds in this circle here is 20, of which 8 of them are red. So the answer to this one is 8 out of 20, which you could simplify and say that that's 4 out of 10 or 2/5 or 0.4. What's the probability that we get a seed from the first packet? That's 20 out of 45. Easy. Okay. So that is that example there showing you how you can use conditional probability but apply to a Venn diagram. Okay, this formula in red is an important formula. It's just a rearrangement of that top one. The probability of A given B happening is the probability of A and B happening divided by the probability of B. This just shows us that we're squeezing down the sample space to just look at the things in the probability of B. So we're given that B's happen, so we can forget everything else. We're just looking at event B. Okay, so that formula there is very important for conditional probability. And it's also important to remember that A and B can be written as A intersection B with that symbol there. Okay, let's look at an example now where we're going to use a tree diagram. This is quite an involved one. In November, the probability of a man getting to work on time if there's fog on the M6 motorway is 2/5. Lots of fog in England, so that's 40% of the time. If the visibility is good, the probability is 9/10. The probability of fog at the time he travels is 3/20. Calculate the probability of him arriving on time. Calculate the probability that there was fog given that he arrives on time. Okay, let's do some tree diagram here. Now, there's lots of clues that conditional probability is involved here. You're going to see words like given that, if there is, those kind of, you have to look for those clues that you're dealing with a question on conditional probability. Okay, so T is the event he gets to work on time. F is the event that there is fog on the motorway or freeway. Okay, so let's get a tree diagram going here. What we want for the first one is PT and the second one is probability of F given that he gets to work on time. Okay, let's look at the tree diagram. So first branches, I'm going to say if there's fog or if there's not fog. The probability of there being a fog on any of these given days is 3 out of 20. Therefore, the chance of there not being fog is 17 out of 20. Now, the next branches is whether he's going to be on time or not on time. Okay, the chance, if there is fog, the probability he's on time is 2/5. Therefore, the probability that he's not on time is going to be 3/5. Okay, if there's no fog on the motorway, the probability that he's on time changes to 9/10. So the probability he is not on time in that case is 1/10. Note that each branch of the tree diagram has got to add to 1. Now we can do some calculations. We multiply along the branches to find the probability of those two events happening. So the top branch is the probability that there's fog and he's on time. The second branch is the probability that there's fog and he's not on time, etc., etc. So we can work out all of those probabilities and then answer the questions, which is what we're going to do here. Okay, what's the probability of him arriving on time? I can see 2 branches that show him arriving on time. That branch there, in other words, that he's foggy and arrives on time, and that probability of 6 out of 100, or the branch where it's not foggy and he still arrives on time. Multiply those two together, gives me 153 over 200. So the probability that he arrives on time, we've got to add these two probabilities together, which we would do on our calculator, giving us 165 over 200, or 33 over 40 as a fraction. And you can give it as a decimal as well. Last one. What's the probability that, given that he arrives on time, that it's foggy? In other words, the probability that it's foggy given that he arrives on time. So it's really important to get those in the right order. Okay, so remember our formula. The probability of F given T is the probability of F and T over the probability of T. So let's look at our tree diagram. The probability of F and T, the top line there, is 6 out of 100. We just worked that one out. And we worked out from part A, the probability that he's on time is 33 over 40. So we just put those numbers in. 6 over 100 on the top line, 33 over 40 on the bottom line, and get our calculator out, and you'll see that that gives us 4 over 55. So there's a couple of examples of using conditional probability with a table, with a Venn diagram, and then with a tree diagram.